Hi, so for this project, my project topic is speaker recognition of MFCC. So for this project, uh, the problems under study. So for the first, I didn't know much about the extraction process of the speech feature parameter MFCC. So recently, I need to extract it manually by myself. So I took this opportunity to study in depth. So for this project in speech recognition and in the speaker recognition, the most commonly used voice feature is male scale frequency substrate. The MMS, MFCC is a substrate parameter extracted in the frequency of the male scale. So we have some existing approach. According to the research of the human ear hearing mechanism, the human ear has different hearing sensitivity to sound waves of frequencies. The critical bandwidth of sound masking at low frequencies is smaller at high frequencies. So because this feature is not dependent on the nature of the signal, it can't make any assumptions and restrictions on the input signal, and uses its research results of the auditory model. Therefore, this parameter has a better looping performance than the LPCC, based on the vocal tract model. It's more in line with the auditory characteristics of the human ear, and still has a better recognition performance when the signal-to-noise ratio is reduced. For the next part, I want to introduce the male scale. The male scale describes the nonlinear characteristics of the frequency of the human ear. The relationship between it and the frequency can be used onto the female. So the F is equal to the 2595 times the log 1 plus F divided 700. So where F is the frequency and the unit is hertz. The following figure shows the relationship between the male frequency and the linear frequency. So we can see is with the frequency become larger and larger, the male frequency also become large. For the MFCC extraction process, it has the 8 process. So the first is continuous speech, and the next one is praise emphasize. Then we can framing, and the next is humming window, and then next we do the FFT, and then the mail filter bank, and the next is logarithm operation, and for the last is DCT. So for this project, we have some project result of we can draw some plots used by the MATLAB of the pre-emphasize and the Hamming windows. So I will show how to draw these two parts. So this is my programming code. So we can see the code here is do pre-emphasize. So we can have this menu. So we have the wave file. So it's named sample. So wave file is equal to sample w, and sp is equal sound processor wave file. Okay. SP equal to sound processor wave file. Hold on. MFCC. So it runs the code. So we have the wave file equal to the sample file. We have it. Then we definition SP equal to the sound process. So we file here. And we give the alpha equal to the 0.97. And next pre-emphasize is equal to sp.do pre-emphasize alpha. Now we can put the pre-emphasize file here. Now you can see the page here. So it has some the amplitudes at during some time. So this is the pre-emphasize plot. And the next we will do the frame blocking. You can define the frame equal to sp dot do frame blocking. Use the pre-emphasize and the parameter 2 is 1024. So I should be the 2 from blocking here, yeah. And it will, we can see it's on the left, it will automatically create the frame file. It may take about 1 minute. So to use the frame file, we can do the Hamming window. So we can use any, for example, the wave is equal to sampling wave, and the SP equal to sound process wave file, and the frame 1 equal to SP 点 reload. We can use the frame 4. Okay. Frame 4.txt and the window frame 4 frame 1 equal to sp do Hamming window use frame 1. Next we can plot the window frame 1. Now we can see with the amplitude and the dimension of this part shows like this. And we also can do another part. We use it's equal to 5 or 6. Never mind. So the wave file is equal to here, SP to here, and frame 2 is equal to this. And into the frame 2 is, I guess we can turn. Now we can draw the frame 2. We can see it's at a little bit different at this side. Also we can do another one. This is This is this part we can do like use a frame 18. Let's pick it. So it can be. Now we can see the Windows properties has changed on this side. So for this purchase, for the possibly the MFCC property will be shown like this. So we can see that the amplitude will be the very big at the middle of this part. So for this project, I also studied for some like proposed a new approach. So on the acoustic model based on the deep learning. So in the earliest neural network used for the acoustic modeling is the most common. By using DNN, the traditional acoustic models such as GMM have the inefficiency of the audio signal representation, but GNN can solve this inefficient representation to a certain extent. But in actually modeling, since the audio signal is a sequential continuous signal, this requires a fixed size input. So when we use the DN to build an acoustic model in the early days, a method can handle change in the length of the voice signal is required. So a DNN HMM hybrid system that combines the HM model and DN model is quite effective for this approach. So for this project, I realized that the variability and the decision making of sound models. So because the sound changes all the time, so in order to visualize the people sound collection and testing, we need to simplify the sound collection. So people set the signal frame number to 20 to 40 AMS and hope to find more in the future advanced methods that are used for speaker recognition and the technologies used in more real-world applications. So thank you for listening. So this is my project presentation. Thank you.